Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Dr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing stoichiometry as one of the crucial topics in the world of science, or that is chemistry to be precise. Now, stoichiometry is that part of chemistry that deals with the quantity of substance used in a chemical reaction. It has to do with what? The quantity of substance used in a chemical reaction. That is the meaning of what? Stoichiometry. Now, stoichiometry depends on three criteria. You have the first one to be the law of conservation of mass. All right. The second one is the relative. This markers, I don't understand. The relative masses of atoms. Number three is the concepts of mole. So these are the three criteria that stoichiometry depends on: the law of conservation of mass, relative masses of atoms, the concept of what? Mole. These are the three criteria that stoichiometry depends on. Please take note of that. Now, the first one you have it to be the law of conservation of mass. This law was first stated by Hans Heinrich Landot and his co-workers in 1906. The law of conservation of mass was first stated by Landot and his co-workers in 1906. This law states that during or in a chemical reaction, the mass of a substance is neither created nor destroyed. I take it again. The law of conservation of mass states that in a chemical reaction, the mass of a substance is neither created nor destroyed. That is the law stated by Landot and his co-workers in 1906. Now, these guys, they constructed a tube called Landot tube. Landot tube. While the tube was empty, it was weighed. After weighing, this tube has A and B. After weighing, what did they do? They introduce certain reagents. Now, the first one is silver nitrates. They reacted silver nitrates with sodium chloride. What do you have here? You have in sodium, you have silver chloride and what? Sodium nitrate. Alright? Silver nitrate was reacted with sodium chloride, being a common salt, table salt, or neutral salt. It is neutral to litmus paper. That is, it is formed. Common salts are formed when strong base is reacted with what? Strong acid. That is, if sodium hydroxide should react with H2S sulfuric acid, you have what? Neutral salt, and it is neutral salt, or to say it's neutral to what? Litmus paper. That is what you have it to be: sodium, silver chloride, and nano to bring sodium nitrate. Then secondly, sodium sulfates was reacted with iron sulfate. Sodium sulfate was reacted with what? Iron sulfate to deposit silver metal and iron 2SO3 2. Okay, sorry. All right. So what do you have here? I have is equation balanced? This silver. Okay. Is it? where is it going? Okay, 4. Sorry, 4. It's not now, what do you now have here? I have I'll put 2 at the back of this place to balance the reaction. Then is ion balanced? Okay, sorry. The first one was actually the right one. Then 2. Is it balanced now? Let us check. 1. What am I doing now? Oh, sorry. What is wrong with me this morning? Sorry, I don't know what I ate this morning. It's like I ate raw frog and it's affecting my brain already. So let's check if the equation is balanced now. 2 silver, 2 SO4 plus 3 plus this one. You now have 3 SO4, then 3 SO4, then you have 2 ion. So I believe it is balanced now. So that is what you have it to be. So these reactions were involved in the law of conservation of mass as stated by Landau and his co-workers. Please take note of that. It is very, very important. Now the next one we are going to be taking is mole concept, or the concept of mole. The concept of mole. What is a mole? Mole, of course, can be represented as numbers. All right, the mole of a substance, you say the mole is a quantity of substance that contains Avogadro's number. Alright, which means that 1 mole of a substance is equivalent to what? Avogadro's number. 1 mole of a substance is equivalent to what? Avogadro's number. Now Avogadro's number is written as 6.02 times 10 to what? 23 gram. Alright, 23 gram. Or okay, let me use the word atoms now. Alright, let me use that word. Alright, so a mole is a substance, or mole is a quantity of substance that contains Avogadro's number. And this Avogadro's number is written as 6.02 times 10 to the power 23. 23, please take note of that. It is very important. Now we have treated some points that are worthy of notes. The next step is the formulas, the various formulas used in stoichiometry. The first thing is to know the meaning and of course the criteria, and secondly is to know the formula, and thirdly their applications. How are they applied in a question? So let's look at the various formulas present in this very topic. Now, you agree with me that number of moles, okay, let me take it up a bit so that everything will just get into it. You agree with me that number of moles, which is denoted as small letter m, is equals mass number over molar mass, and mass number is denoted as what? Small letter m. Alright, then the molar mass of a number is denoted using what? Capital letter what? M. The number of moles is given as what? Mass number over what? Molar mass. Then and the mass number is denoted using what? Small letter m. Molar mass, big letter m. That is the first one. Number of moles is also equals concentration times volume. in cm cube. Cm cube. Right, this is one of the formulas. Okay, these are some of the formulas that we are going to be using. I'm yet to write more. Number of moles, you have mass and molar mass. That is a common formula. Another one is number of moles also equals concentration times volume. All right. Please, concentration is measured in molarity. That is big letter what? M. Concentration is measured in what? Molarity. Denoted as what? Big letter M. Take note of that. The number of moles. Number of moles. Alright, number of moles is also equals concentration times volume. If the volume is in cm cube, you divide by what? 1000. Take note of that. You can also have number of moles. Number of moles is also equals concentration times volume. Now, number of moles at STP, that is standard temperature and pressure. Number of moles at STP, that is standard temperature and what? Pressure. It is when it's in dm cube, of course, STP in dm cube. What I say? That when the volume is given in dm cube, you use 22.4 dm cube. All right, 22.4 dm cube. 22.4 dm cube. But when the volume happens to be in cm cube, that at STP, don't forget the word STP. Standard temperature and pressure. When the volume is a dm cube, you use what? 22.4 dm cube. But when the volume is in cm cube, that is number of moles is equals concentration times volume. That is in cm cube. Now you then use 22,400. all right, 22,400. Let me write at the middle. 22,400. Excuse me, at STP, and you were given the volume in cm cube. It's going to be concentration times volume over 22,400 cm cube. So you have converted. So these are the formula we can actually use in tackling questions. The same thing is also similar to number of moles. Number of moles is equals CV over GMA. That is gram molecular what? Atom. Grand molecular atom. And grand molecular atom is given as what? 22.4 dm cube. So these are the formula with which questions are going to be dealt with. Know when you are expected to calculate in moles, when you are calculated in, please, that reminds me, another formula. Please let me write it up. Another formula. Please, when you are asked to calculate number of particles or number of particles and molecular number, molecular number, you will say number of moles. You say number of moles, which is n, is equals is equals number of atoms, number of molecules over Avogadro's number, which is 6.02 times 10 to the power 23. And this is also equals, in case you also asked to calculate the number of particles, the same things apply. The number of particles is equal, that is over what? Avogadro's number. Alright? So these are the formula with which you can actually, oh god, this marker, let me write it properly please. These are the formulas with which you can actually solve questions on stoichiometry. Okay, so are we good to go? Let us start killing questions. Are we good to go? So the first thing you must note, I gave you 3 criteria. Secondly, the formula, and lastly, we want to apply this formula. All right, we want to use them to solve questions. So I'll rub off the ball. Hope we are ready. The Lord is good. All right, so keep playing this video over and over again for a better understanding. You can also do more findings on this topic to have an in-depth understanding or a better understanding. So that is how it is. We are all intelligent. Nobody is dull. Nobody is dull. So long you are ready to do the right thing at the right time. Okay, let's start with some of the exercises we have here. Okay, the first question says, oxygen can be generated in the laboratory by thermal decomposition of potassium chromate. Oxygen can be generated in the lab by thermal decomposition of potassium chromate. Now, if potassium chromate is decomposed, potassium chromate is written as KL, that is KClO3. If potassium chromate is decomposed, all right, that is thermal decomposition, that occurs in the presence of what? Heat, thermal. It will liberate potassium chloride. Oh god, these markers, they are giving me tough time. Potassium chloride and what? Oxygen. Now the equation is not balanced. What do? Start placing number of moles. You have 3 oxygen here. You have 3 oxygen, but you have 2. All right. So if I should write 1, it would not make any difference. So let me start with 2. If I should write 2 here, it means I will also have to write 2 at the back of this place in order to balance potassium and what? Chlorine. Okay. Then you now have, how many oxygen do you have altogether? 2 times 3, 6. It therefore means that I will have to put 3 at the back of what? Oxygen, to balance the reaction. So this is one thing. Another thing you have to note is how to carry out a reaction using it to solve a particular question. Now, the number 1 says, how many grams of potassium chromate must react to produce 5 moles of oxygen? How many grams of potassium chromate must react to produce 5 moles of oxygen? Okay, it is very, very simple. All right, it is very, very simple. You have, how many moles of potassium chromate do you have here? 2, right? This is 2, and what? 3. How many grams of potassium chromate must react to produce 5 moles of what? Oxygen. 5 moles of oxygen. 5 moles of oxygen. You say 2 moles. You say 2 moles of this. 2 moles of this will produce how many moles of oxygen? 3 moles of what? Oxygen. Then, how many grams of this must react to produce 5 moles of what? Oxygen. 5 moles of what? Oxygen. which means that which means I now have 5. Oh God of Nazareth. So I have X mole. They gave us 5 moles of what? Oxygen. Let me write this one in full. Let me read the question again. How many grams of potassium chromate must react to produce what? 5 moles of oxygen. Alright, to produce 5 moles of what? Oxygen. The question, 5 moles of oxygen means the mole of oxygen was given. So, which means this one wasn't given. That is why we have to calculate for the gram. In doing this, I will now have that X, God of Nazareth. I will now have X mole. Let's to cross multiply. X mole is equals 2 times 5 over what? 3. I now have 10 over what? 3. And that will give me 3 points. Could it be 3.5? 3.5 mole? I don't know. Let me check. So 10 divided by 3. Oh, it's recording. Okay, 3.3. 3.3 moles. Mole of Nazareth. 3.3 mole. I think I'll drop this marker. Now that is not the answer. They said gram. How many gram of this we produced? You know that number of moles. God. What is all this? What is the village people? They are following me. Number of moles is equals mass over what? Molar mass. Is that not correct? You can just do it somewhere here. Let's try this. Potassium is what? Potassium should be 39. 39 plus chlorine is 35.5. Then plus oxygen is what? 16. 16 times 3. That should be what? 48. So what do we get? You have 39 plus 35.5 plus 48. I'll have 122.5 gram. So this is the molar mass of what? Potassium chromate. We've gotten the number of mole as what? 3.3. Then mass is what we are looking for over molar mass, which is what? 122.5. It therefore means that mass is equals 3.3 times 122.5 equals 404.25 gram. Alright, so please take note of that. It is very, very important. It therefore means that 404.25 grams are needed. Okay, that is 404.25 grams of potassium, all right, is needed to produce 5 moles of oxygen. To produce 5 moles of what? Oxygen. We've gotten this. You can interpret it as 404.25 gram of this is needed to produce what? 5 moles of what? Oxygen. That is the first one. That is what? A. Now let's solve for B. All right, so I'll rub off. Let me rub off this one. Then B is how many grams of oxygen can be prepared by the complete decomposition of 8.25 grams of what? Potassium chromate. How many grams? Okay, how many grams? So now they give us 8.25 grams of what? Whatever. So number of moles now is equals mass of potassium chromate over what? Molar mass. Over molar mass. The mass of chromate in the question is 8.25 Then the molar mass is what? 122.5. So let's divide. So 8.25 divided by 122.5, I'll have 0.067, 0.06 moles. Is that the answer? No. How many grams of oxygen can be prepared by the complete decomposition of what? 8.25 grams of what? This. So what do you now have? You now have 2 moles of this will produce 3 moles of oxygen. Then you say 0.06 mole will produce X mole. So let's multiply. Sorry, this space that is here. You say this times this divided by this. So number of moles is equals 0.067 times 3 equals 0.201. 0.201 divided by 2, I'll have 0.10 mole. Alright, but that is not the answer. It's not the answer at all. They said the gram of oxygen, a gram of oxygen. It therefore means that number of mole is equals mass of oxygen over molar mass. Is that not correct? Mass of oxygen, number of moles of oxygen is what? 0.10 equals, the mass is what we are looking for. Of course, oxygen is a diatomic what? Element. So 60 times 2, you have what? 32. So mass is equals 32 times 32 times 0.10, that is equals 3.2 gram. Alright, so please take note of that. Take note of that. It is very, very important. They said how many grams of oxygen must be prepared by the complete decomposition of 8.25 grams of what? Potassium chromate. As I said before, write out your equation. 2 moles of this will produce how many moles of oxygen? This. But the gram of potassium chromate was given to be what? 8.25 over the molar mass, which is 122.5 as calculated in this case, then equals this. It therefore means that 2 moles of this will produce this. Alright, then 0.06 mole will produce what? X mole of, we don't know, of oxygen, we don't know. You now have cross multiplying. When you cross multiply, you'll be having 0.067 times 3 divided by what? 2. You now have what? 0.1 mole. The number of mole of oxygen equals mass of oxygen over molar mass of what? Oxygen. The number of moles of oxygen gotten is 0.10 equals mass over molar mass. Oxygen is a diatomic element, so 16 times 2 you have 32. So 0.1310 times 32, you have 3.2 gram of what? Oxygen. It therefore means that 3.2 gram of, it therefore means that 8.2 gram of this is needed to produce what? 3.2 gram of what? Oxygen. You see, it means that 8.25 grams of this needed to produce what? 3.2 gram of what? Oxygen. That is how to interpret it. Okay, hope this stuff is correct. Let me do it. 16 times 3, yeah, it's very correct. So 39 plus 35.5 plus what? 48. Completely correct. So that is the last one. How many grams of potassium? Okay, I'll rub off. Let me rub off this one. See, How many grams of potassium chloride are produced during a decomposition that also produces 10 grams of what? Carbon dioxide. Very easy. Okay, I said carbon dioxide, sorry, oxygen. It is very easy, same approach. Okay. Okay, so number of mole now is equals, they gave us gram of oxygen. It means that you have 10, that is mass of oxygen over what? Molar mass. Mass of oxygen from the question is 10. Molar mass of oxygen, I said, is what? 32. That will give me 10 divided by 32. I'll have 0.3125 moles. Okay, let me just make it to 2 decimal places. Now, what is the next thing? It means that 2 mole of this will produce 3 moles of this. Then 0.3 mole will produce. Okay, no. Okay, not in this case now. No. Okay, I think. Oh, let me rub off. Which one should I rub off now? Let me rub off this. Let me check this C again. How many grams of potassium chloride are produced during the decomposition? During a decomposition that also produces 10 grams of what? Oxygen. Of course, number of mole of oxygen is mass over what? Molar mass. Mass is what? 10 divided by 32. I'll have what? I think we had 0.31, right? 10 divided by 32 equals 0.31 mole. Good. I just went through the question again, which means the first approach was wrong. So they said, how many grams of this will produce 10 grams of oxygen? Alright, so which means that we've got no business to do with this guy. Okay. Now it means that 2 mole will produce what? 3 mole of what? Oxygen. Good. So it therefore means that 0.31 mole. Okay, let me check, sorry. How many grams of okay. Oh, I get. So, you know this, we have to be very careful the way we solve questions. So we have done this already. So number of moles. Good. This marker is so bad. Not so bad, man. It's bad. Okay, number of moles is equals what? Mass over molar mass. Alright. It therefore means that number of moles is what? 0.31. Something is missing here. Oh. 2 mole will produce 3 mole. Then X mole will produce what? 0.31 mole. Good. So what do? You cross multiply. So this times this, that is X mole of this now is equals 0.3 times 2 divided by what? 3. 0.31 times 2 divided by 3. So you have 0.31 times 2 equals, then divided by 3 equals 0.221 approximately. 0.21 approximately. It therefore means that number of moles now is equal, that is number of moles of potassium is equals mass over what? Molar mass. The mass of potassium is what we are looking for. So number of moles is 0.21 equals mass over potassium is 39. So 39 plus 35.5. So 39 plus 35.5 equals 74.5. So 74.5. Therefore, number of moles is equals this times this. 0.21 times 74.5 equals 15. Is it number of moles now? Sorry, mass. 15.65 grams. So let me take the question again. So how many grams of potassium? Alright, 2 mole produce 3. Then X whatever will produce during the decomposition of produce the good. So this is very, very correct. Okay, so this times this, which means that this times this is whatever. Where's again? This times divided by this, you'll be having what? 0.21 mole of what? This. The number of moles of this equals mass over molar mass, then equals number of moles we got it to be 0.21. We are looking for the gram of what? This idiot. Then over the molar mass, which is this. So this times this, we have it to be what? 15.65 gram. It therefore means that 15.65 gram of this is needed for 10 gram of what? Oxygen. So that is for that. That is for that. Should I solve more questions? Because this one is a bit long. Okay, in our next class, okay, let me solve more question, please. Let me solve more question. I'll rub it off. Okay, I think I saw an exercise here. There's one exercise I saw. I'm going to find it now. Okay, page 56. Page 56, they said, how many grams of carbon 4 oxide is formed when 73.9 gram of propane is burned? They gave us C3H8 plus oxygen to produce, of course, carbon 4 oxide and what? Water. But the equation is not balanced. Alright, you have 3 carbon and you have 1, so just put 3 here. Then after which, what do you have next? You have 8 hydrogen, but you have 2 here, so you put 4 at the back of H. Then how many oxygen do you now have altogether? I have 4 plus 6, that is 4 plus 6, 10, so I'll put 5 here. So it is what? Balanced. It said how many mole? Where is it? How many grams of carbon oxide is formed when dash whatever? Okay, fine. It is clear enough. Therefore, number of moles is equals mass of propane over molar mass of propane. All right. Mass of propane is 73.9 as given in the question. What about the molar mass? That should be carbon is 12, right? So 12 times 3 is 36. 36 plus 8, that should be 44. So 44. Then you now have 73.9 divided by 44. I'll have 1.68 mole. All right, 68 mole. Therefore, 1 mole of propane will give 3 moles of carbon 4 oxide. All right. Then how many mole of this will produce this? Then 1 mole of 1.6 mole of this will produce x mole of. So what do? You cross multiply. So it means 3 times this divided by 1, the same thing. You have now that x mole equals x mole is equals 1.68 times 3 equals 5.04 mole. Is that the answer? No, that is never the answer. They said how many, where is it again now? Okay, they said how many grams of carbon 4 oxide, how many grams of carbon 4 oxide is formed when, okay, carbon 4 oxide, can you solve this now? Okay, which means that this mole now is for what? Carbon 4 oxide. Therefore, mole now is equals mass over molar mass. Then you have to put in your parameters and cross multiply as usual. Number of mole is what? 5.04. Mass isn't given. Molar mass is what? Molar mass of carbon 4 oxide, that should be 2 times 12 plus 32. That should be 44, right? Yeah, 44. Therefore means that M is equals 5.04 times 44. You have 20.76 gram. All right, so that is what you have the answer to be. It therefore means that where is it again? Where is the question again? Therefore means that 73.9 grams of propane is needed to produce how many grams of carbon 4 oxide? 221.7 grams of what? Carbon 4 oxide. You have this number, you also have this 2, which is very easy. Okay, I think we did the reaction before, so just you know what to do now. So K, God of Nazareth, you have KClO3 plus, we balanced it before, then to give potassium chloride plus what? Oxygen. I think we got that before, yeah. Then 2 at the back of this place. Now they said, how many grams of oxygen can be made from 2.47 gram of propane? It is very easy. Number of moles is equals mass of propane is what? 2.47 over the molar mass of propane as gotten before, 44, right? 44. So divide. You have 2.47 divided by 44 equals 0.06, approximately 0.06 mole, approximately. All right, okay. Oxygen and propane, oxygen and propane, oxygen and propane, oxygen and, okay, that's oxygen and potassium chromate. All right, so it means that 2 mole of this, all right, 2 mole of this will produce 3 mole of what? Carbon 4 oxide. 2 mole of this will produce what? 3 mole of carbon 4 oxide. It therefore means that 0.06 mole of this will produce X mole of what? Oxygen. I'm saying carbon 4 oxide is oxygen. 2 mole of this will produce 3 moles of oxygen. Therefore, 0.06 mole of this will produce X mole of this. Cross multiplying, you get a value. Then after which you say N is equals mass over what? Molar mass. For example, you add your N after cross multiplying to be 20. You therefore say M over the molar mass of this. I think we did it before. We had 122.5. So you have the answer to be it. So take note of that. More questions are yet to be solved on this particular part of what? Stoichiometry. Thanks for watching. Do have a wonderful day.